We've long wanted to create something unusual and ambitious. We may not have the finances for full-fledged documentaries and extensive research, but we have the desire to show you something extraordinary, and today, we will do just that. We've set an ambitious task to tell the entire history of our planet in 20 minutes. This is, of course, incredibly brief for all the details. However, it's just enough to give you a broad overview, refresh your knowledge, and introduce you to some very interesting facts about the Earth's history that don't usually make it into textbooks. Our planet is not just about humans. It represents billions of years during which our world has transformed beyond recognition, and entire ecosystems have risen and fallen. Right now, we'll briefly outline everything that has happened over nearly 5 billion years. We'll start our journey approximately 4.5 billion years ago, which isn't too far from the Big Bang that created the entire universe. That event occurred 14 billion years ago, making the Earth only 3 times younger. The formation of our planet coincided nearly simultaneously with the formation of the Sun, at least on cosmic timescales. To illustrate this, if we compress the entire age of the solar system into 24 hours, then our Earth formed from the concentration of cosmic dust in just about 1.5 minutes. Both the Sun and Earth, when looked at from a cosmic perspective, are considered young entities. It's critically important to understand the key point here. These are based on genuine scientific data. Today, conspiracy theories are in vogue, and on the internet you can find whole pseudo-scientific works claiming to debunk the real age of the universe and planet Earth. Allegedly, magnetic fields, oil deposits, and lunar dust layers don't align. There's even a popular book which compiles 107 such pieces of evidence, where one of the arguments put forward is the Bible, which suggests that God created us a few thousand years ago. We have nothing against the Bible. It contains invaluable records of the past. However, it cannot be strictly considered as scientific evidence. In Australia, near Jack Hills, crystals of zircon with an age of 4.4 billion years have been found, and calcium from meteorites has been dated by radiocarbon analysis to even more ancient dates. It's crucial to note that this kind of analysis cannot lie. All radioactive isotopes decay at the same rate, and a simple count of decay products provides a clear estimate of the object's age. So at the very least, our planet and the solar system as a whole are not younger than these dates, and possibly even older. Now let's begin the story of Earth from the protoplanetary disk, a region of gas surrounding a star. Gravity and physics inexorably compel matter to condense, and as it forms in the center, the sun heats it up, causing it to melt. Simultaneously, the force of gravity pushes the lighter elements further away, while keeping the heavier ones closer. As it turned out, the first 4 planets ended up rocky, while the gas giants formed in the outer reaches of the solar system. Earth, much like Mercury, Venus, and Mars, was initially a scorching, and in some places, even a molten sphere, constantly bombarded from space. Radiocarbon analysis provides evidence of this as well. The amount of lead isotopes in the Earth's rock formations and meteorites is virtually the same, indicating that they formed almost simultaneously from the same substance. At that time, there were many more meteorites, and when they collided with Earth, they not only heated it, but also increased its mass, enriching the planet with iron and nickel. Then, just a few million years after the formation of our planet, it faced a terrible ordeal. Another young planet, roughly the size and weight of Mars, collided with it. This planet is called Theia, and the collision was a significant event. Earth, which had just started to cool down, heated up again, and the ejected fragments from the collision formed our moon. Scientists have different theories about Theia. Some believe it had a grazing collision with Earth, while others think their cores merged. But for us, the crucial point is that the moon, according to its composition, is undoubtedly a fragment because it consists of Earth's materials. However, it was much closer, just tens of thousands of kilometers away. The views were stunning, and the collision also tilted Earth's orbit ever so slightly, slowing it down just a bit. Let's fast forward to about 4 billion years ago. By this time, Earth had moved away from the aftermath of the collision. Furthermore, nickel and iron had settled in the core and the surface had mostly cooled. It had also become almost entirely covered in water. You see, each of the meteorites that bombarded the planet carried with them a few drops of water. Now imagine this process occurring over tens of millions of years. Gravity and the unyielding core claimed every drop, and Earth became a watery sphere, more reminiscent of a planet from Interstellar, with huge waves because the temperature back then reached up to 100 degrees and it rotated much faster. Add to this the close proximity of the moon, and you get severe storms and tsunamis. On top of everything else, volcanoes were still present, contributing to the dance with eruptions of magma. However, despite all of this, around 4 billion years ago, give or take, life appeared on Earth. Scientists don't know exactly how, and if they did, we'd become immortal gods. But they generally agree that a combination of factors, including volcanoes, meteorites containing proteins and amino acids, and warm water, played a role. Somehow the emissions from hot springs inexplicably gave rise to the first single-celled bacteria. There are plenty of hypotheses, some of which suggest that life existed even in the protoplanetary cloud, and that living organisms may have existed on Earth before the appearance of bacteria, although there's no evidence of their existence that has survived to the present day. The officially recognized oldest fossils date back to approximately 3.7 billion years and were found in Greenland. However, in Canada in 2017, something resembling life dating back to around 4.28 billion years was discovered. Precise data is challenging to obtain due to the antiquity of these findings, but our understanding of the development of life is quite solid. Around 3.5 billion years ago, simple single-celled bacteria evolved into stromatolites, which you can still see today by looking at the rocks in shallow ocean waters. In reality, these are entire communities of bacteria that photosynthesize, converting sunlight and water into glucose, with oxygen being a byproduct they didn't particularly need. Over millions of years, these rocks filled the planet with oxygen, setting in motion a chain of events that would lead to the emergence of complex life forms. However, it would be necessary to wait for almost 1 billion years for this to occur. Initially, a vast amount of oxygen led to a global ice age. Previously, the atmosphere was largely composed of methane, which created a greenhouse effect. When it combined with oxygen, it turned into carbon dioxide and water. Simultaneously, the sun wasn't as powerful, and Earth experienced a period known as the Huronian glaciation. It was only around 2 billion years ago that the first life forms with cell nuclei started using oxygen for metabolism. Approximately 1.7 billion years ago, the first multicellular organisms followed suit. As you can imagine, this occurred well into the planet's existence. The first algae, for example, had to wait another 1.2 billion years to make an appearance, showing up about 2,200 million years ago. In parallel, the planet's appearance was changing. Before this time, you could still distinguish islands and emerging landmasses on Earth. The planet's core didn't intend to cool down, so it fractured the crust into tectonic plates that floated on the magma, sometimes rising and other times sinking. About 1 billion years ago, the first supercontinent, Rodinia, emerged. Some scientists consider it to be the third supercontinent and suggest that plates had already collided before, but Rodinia is well studied. It existed at a time when a day was about 17 hours long, and nothing more complex than algae existed on Earth. The land was just pieces of rock. Future India was neighboring with the continent of Laurentia. Part of Africa was an island, while the other part was fused with South America. The sad part is that in addition to forming landmasses, the Earth's core also created dozens of volcanoes. When these volcanoes erupted, they led to the formation of acid rain, and the new continents blocked ocean currents, gradually causing the Earth to freeze. There's even a theory that around 1 billion years ago, Earth was completely covered in ice, reflecting all the sunlight back and essentially freezing over. However, since volcanism is a cyclical process, it eventually started to melt the ice, and the global freezing was replaced by global warming. This is how Earth has been moving throughout its history, alternating between ice ages and warm periods. Regarding our most recent ice age, about 750 million years ago, when it melted, it released all the trapped oxygen from the depths of the oceans and glaciers, causing a massive explosion that had consequences for the animal world. This event is known as the Cambrian explosion and is characterized by the sudden appearance of fossils dating back 540 million years. Scientists have found significant breakthroughs in complex life forms in the fossil record. However, more recent research suggests that the process actually began around 750 million years ago when the Earth thawed, and with the increased oxygen levels, animals grew larger in size. Most of them still lived underwater at this point. The supercontinent Rodinia eventually split into Gondwana and Laurasia, and temperatures rose to about 30 degrees Celsius. But Earth was still primarily covered in algae. This was because solar radiation was scorching the planet. However, the increase in oxygen levels helped in this regard by creating an ozone layer. Around 570 million years ago, during the Cambrian explosion, the first forests, ferns, and extensive plant life appeared on the planet. At the same time, land began to attract the attention of amphibian-like creatures resembling lizards, which initially only visited the land temporarily while retaining the ability to live underwater. From this point on, evolution picked up speed. Plus or minus 300 million years ago, when the continents once again merged into a single supercontinent known as Pangaea, Earth resembled a tropical paradise. It was inhabited by giant insects, the ancestors of dinosaurs, and towering trees that reached heights of 30 meters. Remember the high oxygen content in the atmosphere at that time. It's supported by evidence like coal, which is ancient proof of life. This is why the period is called the Carboniferous period. Around the same time, 300 million years ago, the continents collided once more to form Pangaea, giving rise to mountain ranges in the process. For example, the Ural Mountains were created during this period. If you're interested, the Ural Mountains, along with the Appalachians, are much older than the Himalayas with their Everest. By that time, life on Earth was thriving. Insects roamed the planet, along with numerous vertebrates resembling gorgonopsids, and Russia was home to mass populations of scutosaurids, armored reptiles. However, about 253 million years ago, a terrible fate awaited all of them: the Great Permian Extinction. Due to the planet's constant fluctuations between glaciation, volcanic activity, and global warming, there were many mass extinctions on Earth, but the Permian extinction stands out as the most deadly and mysterious. In just 50,000 years, it wiped out 96% of marine species and 70% of terrestrial species. The most likely cause is believed to be the intensified volcanic activity in Siberia. It is thought that multiple eruptions covered the planet in a layer of dust, reducing sunlight, increasing methane levels, and causing widespread suffocation and starvation. However, there is also evidence of a 500-kilometer-wide crater in the Wilkes Land region, suggesting a massive meteorite impact that occurred around the same time. The horror of the situation is compounded by the fact that even insects, which are known for their resilience compared to other creatures, perished during this event. It may have taken up to 30 million years for the biosphere to recover after the Permian extinction, but as they say, every cloud has a silver lining. The vacant Earth was soon populated by archosaurs, descendants of the few reptiles that miraculously survived the extinction. Around 230 million years ago, the real giants emerged, the ones we love to watch in movies today. To grasp the grandeur of their era, consider that they lived on Earth 50 times longer than humans have, if we count from the very first human-like primates. 200 million years ago, they firmly established their dominance over the planet, which would last until the late Cretaceous extinction about 66 million years ago. However, there are a couple of points that often don't make it into textbooks. Firstly, dinosaurs did not go extinct entirely. Modern birds belong to the theropod order, and scientists have long referred to them as feathered dinosaurs. It was only the so-called non-avian dinosaurs that went extinct. In fact, you can consider modern chickens as very distant descendants of dinosaurs, and they too had feathers, as evidenced by modern reconstructions. Secondly, let's talk about crocodiles. It's often claimed that crocodiles are older than dinosaurs, and that's only partially true. The crocodile family did indeed appear almost simultaneously with dinosaurs around 240 million years ago. However, these were quite different creatures. They were larger and could easily prey on 9-meter-long dinosaurs, dragging them into the water. Furthermore, for several tens of millions of years, it was the crocodiles that ruled the planet, while dinosaurs were a scared bunch of reptiles. Within the crocodile family, there were creatures resembling wolves and even some that walked on 2 legs. Not all of them were predators. Some remained herbivorous. It was only about 200 million years ago that an unknown biological catastrophe wiped out the crocodiles, and after that, the dinosaurs took over both land and sea, where huge marine reptiles like plesiosaurs thrived. Crocodiles had to retreat into rivers and swamps, where their descendants still live to this day. They became smaller, and the modern forms only emerged about 80 million years ago. Thanks to their adaptation to river habitats, they survived the mass extinction event that killed off the dinosaurs. However, they couldn't regain dominance as mammals took over, but more on that later. For now, let's return to the era of dinosaur dominance. During the age of dinosaurs, the climate on Earth was warm, and there was no sign of Antarctica as we know it today. Reptiles comfortably inhabited both the northern and southern regions because ice sheets were nearly absent. The old supercontinent, Pangaea, began to break apart about 190 million years ago. Initially, two major land masses emerged: Laurasia, consisting of what is now Eurasia and North America, and Gondwana, encompassing everything else. Even Antarctica had a climate suitable for life. The separation of continents during this period didn't significantly affect the dinosaurs, as they continued to evolve. However, around 180 million years ago, the familiar Atlantic Ocean began to take shape, and the boundaries between continents started drifting apart even further. The emergence of tiny mole-like creatures that fed their young with milk was a significant development during the era of dinosaurs. These small animals, weighing only 5 grams, seemed insignificant compared to the massive dinosaurs, but they introduced a new stage of evolution: lactation. Their small size made them unassuming prey in the presence of giant dinosaurs, and this helped them survive the last mass extinction event, which occurred 65 million years ago. The causes of this event are still unknown, but the massive crater on the Yucatan Peninsula, formed by the impact of a 10-kilometer-wide asteroid, provides a clue. To put it in perspective, the impact of such an asteroid was 2 million times more powerful than the largest nuclear device ever created by humans. Even relatively minor events in Earth's history, such as a series of eruptions in the year 536, led to the planet being plunged into darkness for 18 months, resulting in famine and a crisis that lasted for 100 years. Now imagine what would have happened with an explosion thousands of times more powerful. The dust, soot, and molten rock ejected into the atmosphere caused fires all over the world. The shockwave awakened volcanoes, and through computer modeling, scientists have concluded that photosynthesis on the entire planet was halted for 2 years. Temperatures dropped by 28 degrees, the stratosphere shielded the Earth from sunlight for several years, and tsunamis reached heights of 100 meters. Naturally, this didn't instantly kill all the dinosaurs, but it's challenging to understand how multi-ton creatures could breathe, find food, and survive under such conditions. While it's not solely the meteorite's fault for the 5th mass extinction, it undoubtedly played a significant role. From the perspective of mammals, it was a positive event, because they, along with surviving birds, snakes, and crocodiles, quickly moved in to occupy the territories left vacant by the dinosaurs. Around 50 million years ago, mammals experienced an explosion in their evolution, resulting in a proliferation of species. It's worth noting that by then, a day was already nearly 24 hours long, and the average global temperature was similar to today's. The ability to give birth to live young, warm-bloodedness, and a developed nervous system turned small, harmless mammals into the kings of ecosystems. This period marked the emergence of the ancestors of pigs, deer, the first predators, and eventually, the ancestors of primates that would lead to fans of Japanese cartoons sitting on their parents' shoulders. It's important to remember that for 2/3 of their history, mammals remained on the sidelines, and their dominance has been 3 times shorter than that of the dinosaurs. So we still have much to prove in terms of our superiority. And then the Earth continued its history and gradually approached the form we know today. Antarctica, for example, was covered in ice just 34 million years ago, turning from a rich and thriving region into a freezer. There is no mystique in this. The poor continent simply found itself in the wrong place at the wrong time. After splitting from Australia, it drifted towards the pole, and then a cold current formed around the continent, preventing warm waters from approaching. Somewhere around 14 million years ago, poor Antarctica froze completely. Moreover, there is evidence that at least parts of it periodically thawed. This happened a couple of million years ago, and was again related to the Earth's cyclical process of warming and ice ages. Glaciers periodically reached almost to the equator, and, in turn, retreated, exposing Antarctica. However, for mammals with incredible adaptability, this was not a problem. They continued to evolve. The oceans, freed from dinosaurs, were inhabited by whales, while on land, felines and horses roamed. Primates are much older than textbooks usually state. They are considered some of the oldest species of placental mammals. The primate order, including apes and monkeys, emerged a whopping 80 million years ago, and the oldest known representative, most similar to a monkey, was found in remains dating back 45 million years. So, technically, our very distant ancestors lived alongside dinosaurs. It was around 6 million years ago that the last common ancestor of humans and chimpanzees appeared. Subsequently, the evolutionary paths of primates and humans developed separately. Beginning with this relatively tiny period in Earth's history, the era in which we live began. Although it would be more accurate to say that it didn't start with this period at all. 6 million years is not even half of the time it took for dinosaurs to establish their dominance on the planet. It's not excluded that billions of years from now, no one will bother with us either, and when summarizing the planet's history in 20 minutes, we will be grouped with the first Homo ergaster, who lived 1.5 million years ago and first discovered fire. And they will be absolutely right, because we differ much less from a working human than a Tyrannosaurus differs from its ancestor, Tavahali, which lived 100 million years earlier. The development our species has undergone in just a couple of million years is a tiny speck in the backdrop of the evolution of other species. However, for the sake of fairness, it's worth noting that humans evolve much faster than past dominant species, but to consider us an exception would be foolish, as it has always been this way, and new species always evolve faster. There are several key milestones in the history of the human race. 6 million years ago, humans split from chimpanzees. Tropical Africa became drier, and some apes moved to the land, gradually beginning to walk on two legs. Moreover, remains of bipedal primates are now found not only in areas that have turned into savannas, and the question of why the heck the little monkeys exchanged trees for flat ground has once again gained attention. But now it's not interesting to us. What's interesting is that around 3 million years ago, the first Australopithecines began to roam the Earth, including the recently discovered Lucy. They only vaguely resembled humans, but somewhere along the line, the first Homo appeared. They were called Homo habilis, or handyman. Starting their history around 2.8 million years ago, they marked themselves by creating the first primitive tools. Nothing special. They simply split rocks in half and used the sharp edge. This was a revolution on the planet even more significant than the invention of the internet. Homo habilis was eventually replaced by Homo faber, the working man, who, according to recent scientific data, ignited fire for the first time about 1.5 million years ago. Then came Homo erectus, the upright walking human. Due to the antiquity, it's difficult to determine exact dates, and it's important to understand that various branches of human evolution lived together for tens and sometimes hundreds of thousands of years. For example, recent research claims that fully upright humans lived 2 million years ago, which is when the last Australopithecines did not yet go extinct. The differences between these species are so blurred that Pithecanthropus, Atlanthropus, and Heidelbergenses are also classified as Homo erectus, simply because scientists cannot precisely define the temporal and physiological boundaries that separate these species. We only know that 500,000 years ago, our ancestors were already gathering in so-called clans and living together. They could also hunt large animals, bury corpses, and somehow care about hygiene. Stone tools have been found in remains dating back 700,000 years, just so you understand how serious it all was. Somewhere around this time, people began to take care of each other, as evidenced by remains of toothless individuals and individuals with skeletal impairments, where relatives helped them survive. Another remarkable earthling appeared 500,000 years ago, the Neanderthal. These guys turned out to be a dead-end branch of evolution and went extinct about 30 to 40,000 years ago. The pedestal of honor was taken by the good old Homo sapiens. It is believed that they branched off from Homo erectus about 120,000 years ago. The oldest remains found in Ethiopia are dated to 195,000 years BC. It is commonly believed that we are these very folks, but in reality it's more complicated than that. Yes, we hardly differ from those who lived 100,000 years ago in terms of brain and body structure. Nevertheless, from a scientific perspective, it is correct to refer to us as Homo sapiens sapiens, i.e., humans of modern anatomy, while the most ancient, Homo sapiens, have been categorized as a separate species, which is considered extinct. Nonetheless, the modern concept of humans as the rightful rulers of the planet was established approximately 40,000 years ago when they spread everywhere and reduced the populations of competitors to a minimum. To say that this is just a moment in Earth's history is an understatement. It's even less than that. If we use the popular comparison of Earth's history to a single day, armed with modern research, the picture becomes quite bleak. If the planet was born at midnight, single-celled algae would appear by 2:01 p.m., trilobites at 9:01 p.m., dinosaurs at 11:01 p.m., and humans just a minute before the end of the day. And if we consider the appearance of modern humans, we're talking fractions of a second. Yet, in such a short time, the thinking human achieved what no one had done before. And I'm not talking about inventing anime, I'm talking about the first states. Unfortunately, this invention brought to the planet the old tradition of large-scale wars leading to destruction. Finding the very first state on Earth is almost impossible. Traditionally, Sumer is considered to have formed the earliest state-like entity around 4,000 years BCE, almost simultaneously with the ancient Egyptians. But any person knowledgeable in history will look at this data with a smile. After all, the Sumerians, in their records, were already building upon the experiences of some ancestors, the knowledge of which has not reached us. There is evidence of city-states in the territory of modern-day Turkey dating back to 8000 BCE. India claims that its proto-state emerged 8,000 years ago. Moreover, nearly every self-respecting country insists that tens of thousands of years ago, there were already cities and bustling life right here. In general, it can be reasonably assumed that they are all correct. At the very least, it's naive to think that, having learned to live in groups hundreds of thousands of years ago, people only created the first nations 6,000 years ago. This period is more about the invention of the very concept of a state. Independent cities and alliances existed much earlier. Historical records even document trade activities between Neanderthals and Cro-Magnons in ancient times. Part of the problem is that for thousands of years, Christianity prohibited even thinking that the Bible might not be entirely accurate and might not cover the entire span of human existence. This hindered research during times when ancient artifacts were more accessible. Ancient cities were destroyed, dismantled for spare parts, and often simply burned in the wars that followed one another for thousands of years. Consider the Spanish conquistadors, to whom the Inquisition entrusted the burning of all Mayan records. Now we cannot understand where they came from and what they were doing. So ironically, the modern period of human life, which began 6,000 years ago, is even more challenging to study than dinosaurs, whose religion offended no one, and whose cities couldn't be burned because reptiles didn't have cities. Alongside the development of writing, the art of deception also progressed, and it would be foolish to trust everything left to us by ancient historians. But it is something we can and should investigate, which is precisely what we do in our videos. Now, this video is coming to an end because, as you now understand, the history of Earth is so ancient that in terms of billions of years, the Roman, British, and other empires are not even a speck. They certainly deserve similarly lengthy videos, and we will happily organize them, provided that you enjoyed this format of long videos. If you liked it, we'll be waiting for likes and comments with suggestions for future extensive episodes. But for now, that's all from us. See you in other videos.